A displacement d of 100 meters from the origin at an angle of 370. Oh, so it's supposed to be actually 37. 37 degrees above the x-axis is the result of 3 successive displacements d1 of 100 meters along the negative x-axis, d2 of 200 meters at an angle of 150 degrees above the x-axis, and the displacement d3, which we don't know. So we're asked to find a displacement d3. So whenever you're told that something is a result of the other displacements, it simply means it's actually as a result of the addition of their x and y components. So in this case, d being the result of the other displacements, it should be actually on the bottom. So meaning that the x components of d1, d2, and d3 were added for them to get the x component of y of d. Sorry. So we are going to resolve our resultant, which is displacement d. So whenever you're given a question on vectors, make sure you draw this table to resolve the vectors that you're given in the question into their x and y components, so that your calculations and analysis are made simple. So knowing that we have d there, we should resolve d using these formulas into its x and y components. So knowing that our x component is actually equivalent to the arrow, which represents the magnitude of a vector. So in this case, we know that it's 100 for d. So it will be 100 cosine the angle. So our angle is 37. Okay. So using your calculator, 100 cosine 37 is just 79.9. So we can indicate it there as our x component, 79.9. Moving on to our y component, which we know should be now 100 sine 37. 100 sine 37. So 100 sine 37 is 60.2. Okay. So this is what we call resolving vectors into their components. So we've resolved d, which is the resultant of the other displacement, into its x and y component. We can now resolve these other vectors that were added to get the resultant d1, d2, and finally d3. So we move from d1. So d1 is actually 100 meters along the negative x-axis. So 100 meters along the negative, meaning it's this way. And since it's along the negative x-axis, it will be negative 100. Okay. So what is the x component of this displacement? It's actually just negative 100, as even stated in the question. Okay. Then the y, any vector that moves either along the negative x-axis and the positive x-axis, the y component is always equal to 0. Equally, this applies when any vector that moving along the y-axis, either the positive or the negative y-axis, the x component is always also equivalent to 0. D2 is actually 200 meters at an angle of 150 degrees. So this is likely to be in the second quadrant, making an angle of 150 degrees. Okay. So again, we use our formulas. This one for the x component, that one for the y component. So knowing that our r is 200, so it will be 200 cosine theta for the x component, 200 cosine 150. So 200 cosine theta, which is negative 173.2. The y will be 200. Instead of cosine, it will be sine. 200 sine 150. So instead of cosine, for the y it will be sine 150 for the y. So that will be exactly 100. Okay. So knowing that we don't know what our x component is, we don't know what our y component is. And since we've resolved the displacement into their components, okay, so this is our d. So this d is actually the resultant of these three other displacements. So meaning these were added for them to get this. Okay. So for us to find what's missing there, we should ask ourselves, when after adding this and this, what should we put there to get this? So you can come up with any variable that you would want to put there. So negative 100 plus negative 173 will just be negative 173.2. The positive times negative is negative, plus the unknown x should give us 79.9. So after adding, negative 100 minus 173.2 just be negative 273.2. So crossing the other side, it would be 79.9 plus 273.2. So 79.9 plus 273.2 is 353. So that one becomes our x component. Okay. 3.1. Looking now at the y. So our y will then be 0 plus 100, which is just be 100. Then we don't know our y. So but we know that it should be equivalent to the resultant y component, which is 60.2. So 60.2 should be subtracted by 100. Okay, we add negative 100 both sides. This will cancel out. So 60.2 minus 100 would be negative 39.8. Okay, so negative 89.8. But the question was not asking us to find the components. The components are just going to help us to find the actual vector. So how do you find the magnitude of any given vector? So it is important to note this formula, that whenever you want to find the magnitude, it is always the x component, which should be squared, plus the y component squared. This is actually derived from this, knowing that this is your vector and resolving it into the x and y. This should be your x, this being your y. Okay, so that being your d3. So by Pythagoras theorem, we know that the square root of the hypotenuse, which is the vector, should be equivalent to the other two adjacent sides, the square root. So by making d3 subject, you come up with something that is like this. Okay, so what is our x component? Our x component is 353.1 squared plus our y, which is negative 39.869 squared. So make sure you put the negative inside the brackets. Okay, so punching that on your calculator, it will be negative 89 squared plus 53.1 squared. Then finding the root of that, it will be 355. So 355.3 meters as given in the question. So this is our D3 that we asked for. But remember that whenever you're dealing with vectors, it is also important that you should also find the direction, whether it is stated or not stated in the question. Otherwise, you will not get the full marks. So, therefore, let me just create some space. Knowing that we should use tangent to determine the direction when we know the x and the y components. So it is always tan of the angle should always be divided by the adjacent, which is the y, divided by the x. Okay, so let me create some space here. So tangent, so it will be tan inverse, okay, of what is our y? Our y component of what we found is negative 39.8 divided by 353.1. So this is tangent inverse, since it has come on the other side. So when this moves to the other side, it becomes the inverse. Okay. So punching that on your calculator, negative 9.8 divided by 353.1, then tan inverse is negative 6.4 degrees. So make sure that your angle should not be negative. So knowing that it's negative, so it's below the positive x-axis, 6.4. But our angle, according to vector rules, we're supposed to measure it in relative to a positive x-axis, this way. Okay? So every full revolution is 360. Okay? So we need to subtract the 6.4 to get the angle in relative to positive x-axis. So 360 minus 6.4 would be 353. 353.6 degrees. So therefore your answer will be 4 by putting a comma and rewriting the direction. 353.6 degrees. So like this, you've answered the question in full and you get the full marks. Thank you very much for watching. Subscribe to get more videos on questions on different topics in mathematics, physics, and other science subjects. Good day.